Okay, we go. Right, this is Charles Sterling from Sterling Power. This is my first time doing this, so bear with me a bit. The whole point of this video is to show how you can get some decent power on a new Euro 6 or new vehicle where you might want, in your camper van, you might want to run a induction cooker, microwave, mostly hair dryers, fridges, etc. So I'm just going to go through a few things here, and we'll just see how this works out. So where we're going to start at is that the new vehicles coming out, so you're basically talking like this bit here is the vehicle. Now the new vehicles coming out have got very big alternators on them because they want to do the Euro 6 regen braking. Now, to make life easy for you and not have to go through everything again, I can suggest you look at this here on the internet. This explains to you what regen braking is, why they do it. There's lots of downsides with regen braking, but there's also a few upsides. And one of the upsides is that the alternator now has been increased to somewhere around 180 to 250 amps. Now that's a lot of power. That's 2 kilowatts. So these days you're running around with a 2 kilowatt generator under your bonnet of your car that most people don't even know that's there, and then they run out and they go and buy a portable gen set when they already had 2 kilowatts under the bonnet. So the big problem now is, how do you get the 2 kilowatts from under the bonnet to your vehicle? So at the moment what you have is basically your alternator, power comes out of your alternator, goes down to sort of your starter motor area, and then from your starter motor to the positive terminal of the battery. Now a lot of other vehicles these days have 2 batteries, and they have a second battery on board, like a Ford Transit or something, and then they have a relay which then goes to the second battery. Now this is fine, the second battery is good, but the limitations with this system is the fact that the relay is probably about 60 amps, and you'll find if you read the small print, your limitation to charging through this system here is probably about 30 amps. Now from the point of view of being of any use, it's just not. I mean, when you start going into high powered systems, trying to take advantage of 180 amps here, and your limitation through here is 30 amps, then you can see that this is just a waste of space. This particular battery here is purely there for if you want to run flashing lights or some small thing on your vehicle, but it's extremely limited, and from our point of view is a complete waste of time. But you will find these second batteries on your vehicles, or some of the vehicles. I would strongly suggest you just ignore them or take them off or whatever, but they're not much use. So what we're trying to do is get 180 amps out of this alternator, and getting 180 amps into the system, or as much as power as possible. So because of the problems with the Euro 6 regen braking, which I've said, I recommend you'll have a look at this here first. As I said, what this is all about is that the alternator voltage now, instead of being like 14 volts dead, goes away up to about, in some cases, 17.5 volts and down to about 12.4. The whole point being that you only charge the battery under braking or slowing down conditions. In other words, the electric that is used to charge the battery is free, and this may give you 1 mile per gallon extra around the town. I'm not sure of the figures, but that's certainly the idea of it. But the downside is that you're running now from 17.5 volts down to 14.4 volts, and at 12.4. At 12.4 you're not charging your battery. In fact, it's discharging your battery to leave a 20% gap in order for the regen braking to work. It's all explained in the regen braking thing. I don't want to go into any big details over the regen braking Euro 6, but that information is there. So if we start off with the sort of vehicle, what we want to try and do is leave the vehicle as much alone as possible, because the vehicle's got all sorts of electronic control systems, the voltages are very high, the voltages are very low, and we want to try and leave the vehicle alone. So we do a new product called a battery-to-battery charger here. Now what the battery-to-battery charger does is when you're down to 12.4 volts, it'll boost it up to 14.4 or whatever you set it at, and when you jump away up to 17.5, it'll drop it down to 14.4. So you can put sort of between 18 volts into this and sort of, you know, down to about 12.4. In fact, you can actually go way down to about 11 volts. And then we will take that power, boost it out, and give you a steady 14.4 or whatever you set it at to charge the batteries to the other side. The other big thing with this product is it's what's known as current limiting, which means that if you put a 30 amp version on, you only get 30 amps through. You put a 60 amp version on, you get 60 amps through. This isn't so important when you're doing normal batteries, but it is very important when you're doing lithium, and we'll come to that later. So not only is it doing voltage control, it's doing current control as well. Now, in order to fit that, it's actually very simple, as the name would, you know, suggest. It's charging from one battery to another battery. So it's, you know, there's no big skill set here. You simply take a wire from your starter battery, go into a fuse. The fuse, if this was say 60, that's got just says a 60 amp, and the fuse would be about an 80 amp. That would be a you know, in that particular fitting is one of ours, is a mini ANL. So out of there into that, out of that into that, and then down to the positive side of your batteries. So it's you know, doesn't get any simpler than that. As the name suggests, it's a battery-to-battery charger. So we'll put an 80 amp fuse going in, and we'll put, say, you know, a 70 or 60 amp fuse coming out. That goes to the positive side of the battery. Now, the most important thing also with all this is that the negative must be a common negative, and the negative we try not to do, what we try not to do is use the chassis, because the chassis has got a very bad negative. It's metal, you know, steel. The connection to the chassis is usually very bad. So what we strongly recommend is that the negative from the batteries goes to a common negative to here, which then that negative there goes to the alternator. So rather than, you can put it down to the chassis as well, but, you know, just as a grounding thing rather than transmitting power. So this is what's known as a common negative. This negative can come out of here. It doesn't matter whether it goes there. It doesn't matter whether it goes there. It doesn't matter whether it goes there. It's a common negative. So, you know, put it to the common negative. Exactly which direction you go really doesn't make any difference. So we'll just take that off just to tidy things up a bit. And we'll just put it to there, just, you know, just to get this job done. So tidy the wires up. Right, so we've got as far as putting the battery-to-battery charger on. We make this battery-to-battery charger 30, 60, or even you might want to put two of these on. For example, this is this particular one you're seeing there's a 60 amp. You might have, say a 200 amp alternator here. Well, it's 60 amps here, 200 amps here. There's room for more, so you could probably put two of those on. So that gives you a total there 120 amps. So you don't want to go to the full current of the alternator, because bear in mind that the vehicle itself needs power to run. Also, you'll overheat the alternator and melt it. So it's good to keep a sort of 20-30% reserve in the alternator to stop any problem. So you can put two of these on, you could put three of those on. If your alternator is bigger, you could put a 60 and a 90 or 30 on to make 90 amps. It doesn't matter. These units can just simply be added on or taken off, and then the unit itself can be adjusted by 10%. So you might want 80 amps, you could put a 60 and a 30 on and drop 10 amps out of one of the units. So fully adjustable, but you want to try and get as much out of your alternator as you can and put it into your batteries as fast as possible. Now, moving to the batteries, again, all the stuff you see on the screen is stuff that we do here, and there's reasons for it. So if you move to your batteries, we're talking about lithium versus lead acid. Now there's a what do you call it? And there's a unit here somewhere. Here we go. So if you go on to this here and check that out, I spent 6 months doing a test, testing lithium against lead acid. you just can't get the right figures out of lead acid companies. The figures are not suitable for what you're using the battery for. And the big question is lithium better? I can assure you lithium is off the scale better. It's not 10% better, it's not 20% better, it's hundreds if not thousands of percent better. So watch that video there. Well worth it. Lithium is by far the cheapest battery you can put on if you're looking for longevity. You will be changing normal batteries at a rate every year, if not every 2 years. The lithium will last you 20 years. You just simply take it off that vehicle, put it on the next vehicle, and off you go. So lithium is way, way better than anything else. But just for this test here, what we've put on is, or this drawing, we've put on here 300 amp hours of lithium. Now, the other big advantage of lithium is when you say you put on 300 amp hours, you get 300 amp hours. If you put 300 amp hours of lead acid on, the first day you will get 300 amp hours. Very rapidly after that, you will get a hell of a lot less. So with lead acid, we say to average it out, you would get 150 amp hours if you were to average it out, lead acid versus lithium. So that's equivalent to almost 6 lead acid batteries. It'll last you 10, 15, 20 years, and it's also a hell of a lot lighter. So we've recommended lithium on this particular drawing here. Now, if we move on further down the system, we want to get 240 volts onto the vehicle. Well, we're in this particular instance using the Combi. Now, this is the most prolific product here when you're going to use inverters and chargers and crossover switches all in the same box. So this particular product is 2.5 kilowatt pure sine wave inverter, an 80 amp 12 volt charger, and it's also got a 30 amp crossover switch. So you can put 240 volts into this. So the for example, the shore power, I'm going to put the shore power in torque-wise. So the 240 volts will go in here. So you put 240 volts in, then there's 240 volts comes out. And then on this side here, you have the 12 volts, and well, that's pretty much it. So the positive of this here would go, now put that shunt on here, I'll explain that in a minute, to a larger fuse to the positive. The negative just remains common and goes to the negative as per the other negative. Now what I've done here is this is a shunt, and what a shunt is doing is measuring current. It's not so easy to write on this, and this is the GFH8 fuse with a, say, a 400 amp fuse in it. Now, basically we're coming from the positive here to the shunt, through the shunt to the fuse, from the fuse to the unit. Now, what the Combi does, as I said, gives you 2.5 kilowatts at 240 volts, plus inside here there's the automatic crossover switch, so that when you do put 240 volts in here, it says, okay, there's 240 volts coming from the shore power, we'll put it through here, straight out here into the vehicle, and then inside it becomes a battery charger, which then charges the battery down here. So it's an inverter, it's a charger, and it's got an automatic crossover switch. Basically, if you're plugged in on the shore and somebody disconnects your shore power, you won't even know it's been disconnected, because you'll simply cross over onto inverter. So 2.5 kilowatt pure sine wave inverter. Now the reason for the shunt here, is what that's all about is, if you've got a larger battery bank, it's always nice to know, well, what's going on there, how much electric is in it, how many amps are in it, how many we used, how many we got left, etc. So this product here is a power management panel, and the key thing here is this bit here. Now that's telling you on that particular drawing there, it's minus 435 amps. So that means that on this drawing, which isn't relevant to this thing because we've only got 300 amps of batteries, but if you had a 600 amp battery bank, it would be saying you have used 435 amp hours, therefore you've only got, less than a couple of hundred amps left. So that's the important figure there. But in order to get that figure, you have to measure the amps here and multiply that by time. Now the amps comes from this shunt. So this shunt here can tell you connected to here, and that tells you how many amps are going through that shunt that way, and then how many amps are going through the other way. And that tells you how many you're charging and how many you're discharging, and then mathematically it works out the amp hour. So it can tell you that in that particular battery bank, so you start off with it full, that you've used 10 amp hours, 20 amp hours, 100 amp hours, 200 amp hours, whatever, and at 300 amp hours you're going to run out of juice. So that's what that panel tells you, and then when you charge back up again, it will go the other way around. Now, people will notice that I've wired this up wrong, and I will explain to you why in a second. A shunt only works when you put the current through the shunt. So I have wired this up incorrectly, but I will show you what I've done. It's probably not a bad thing. So the power should come from the battery bank there. The difference is that when you put a shunt on, you shouldn't put that wire there. That wire should go to the other side of the shunt, and then that shunt goes to here. So in other words, all the current is going through the shunt. So when I'm charging, I'm coming down here, through here, backwards into the battery bank. When I switch on the charger in the Combi, it's going down here backwards into the battery bank, and then when I am using the batteries, the juice is all going this way. So everything should be connected to this side of the shunt. The only thing on this side of the shunt here should be to the batteries. There should be nothing else directly connected to the battery. So if you're using a panel like this here, then you've got to put everything to that side of the shunt. So I will just tidy up my little mistake a bit better. Take that off there, take that off there, and we'll move a bit further on. So let's get rid of all that stuff there. So try and keep it less confusing. Move this over a bit. Good little program this, it's just me getting used to it. Right, so we've got the fuse in, we've got everything else in. Now the Combi, as I said, the Combi is 240 volts and 12 volts. So we'll put the 240 volts in, so we'll put the 240 volts in purple. So you'd have the side of your vehicle, and you'd have a shore power connection here, and this shore power would come up and go into the Combi. Now that's going into the Combi, and then from the Combi you take it out and go to your RCD. So this is a standard RCD, nothing special about it. It's got your earth leak detector here, and then it's got a couple of sockets for ring mains. Bought in your local electrical store, just earth leak detector. You'll know by the picture, you'll soon see it. That's a safety requirement, and we strongly recommend you use it. So anyway, shore power here, into here, 240 volts out there. Then from that 240 volts, we connect up. You would have two ring mains on this. So let's just pull two ring mains out, and go over here with the two ring mains just because I'm running out of space. Now over here we have our hairdryer, we have our fridge, microwave and induction hob. Now the interesting thing with this is the fridge. I've used a 240 volt fridge. Now there's a lot of controversy. Is a 240 volt fridge better than a 12 volt fridge? Now I did some tests which would be under this bit here, and the end result was we used a Combi like this here. The end result was that it was 6 to 1, half dozen the other. The only thing I couldn't distinguish whether the running a 240 volt fridge through an inverter or running a 12 volt fridge only, there was no difference from the point of view of energy consumption. Where there was a massive difference was from the point of view of cost. So the fridge, your 12 volt fridge was like £600, and the 240 volt fridge was about £80. So there was about a £500 saving with the fridges, and that was the only thing that I could see that was any difference. All the tests are there, all the figures are there. So by saving £500, to me that went towards the cost of the Combis and the cost of the electrical system. So but that's a choice you would have to make. But I'm just saying that, you know, the 240 volt fridges do tend to be a bit better. They tend to be more reliable, certainly cheaper, and The only thing I found you had to do was put a child lock on the door in order to stop the door flying open as you're driving along the road. But outside that, I think you got a better quality system, for a lot less money. So the induction hob here is about, say, an 1800 watt one. We try and use the lower powered one. These are available from us. Now, the advantage of these is that the power split. So if you only have 1800 watts and you turn this one up to, say, 1200 watts, then it will only put 600 on the other side. But you can change that bias. You can put more power on this side here and less power on this one, but the total will stay within the the range of the product. So you can certainly get hobs that are very powerful. The trick is to get a hob that is low powered, not high powered, and then you can share the power. So again, you can get that from us if you're interested in induction hobs. But this is really what this is about, is getting induction hobs onto your vehicle and getting rid of gas. So we've got the 240 volt system on there. So let's see what else we've got on here. So you've got your normal distribution panel. This is a new distribution panel we're working on, which to be fair isn't quite available yet. But again, that distribution panel would connect to there. So anything that your system's going to use on your vehicle will go through the distribution panel. So as I said before, all roads lead to this connection here. No wires go to the other side there whatsoever. Then we're getting asked a lot about solar. Well, solar, it's really up to you. If you're running around Europe, then solar can make a lot of sense. If you're running around the UK, I'm not too sure solar's the greatest thing, but anyway, people want it, so it's there. So our flexible solar cells go from about 80 watts to about 150. Obviously, they're different sizes as you get bigger. So you can just flood the roof there. They just silicone onto the roof, and then you connect them through this fitting here, which goes through the roof. The sockets here will fit into here. This goes through the roof, seals everything on the roof. Again, this is our unique fitting here. I better go back to red again and put the actual wires in. Otherwise, it'll get really confusing. So take all that out there. So just as many solar cells as you want, as many as will fit, the more the merrier, as they say. So they'll go from there into here, through the vehicle, down there, and then into the solar regulator, and from the solar regulator again back to this point here. So that's your solar. You can put as much on as you want, as little on as you want, not bother with it, but the solar must go to this side again in order to be counted with this panel here in order to work correctly. So that's pretty much the circuitry for putting a Combi onto a vehicle. It's quite simple to do. It's primary school maths. If you get the maths wrong, the only person you're kidding is yourself. The two main things is to get as much power as possible from the alternator to the battery bank. So as big a battery bank as possible from as big an alternator as possible, and then do the maths and make sure you're maximizing everything through the battery to battery charger. As I always say to folk, if you get this bit here right, then you'll have power coming out your ears. So get the transmission from the power into the battery, then you've got loads of juice, and then you can do whatever you want with the juice. There's no reason why this can't run a fridge for 4 or 5 days if you're just running fridges and things. It'll do your cooking, it'll do your microwave, get a lot of power stored up so you can, you're going from site to site. When you go on to sites, you don't need to be wasting the money on the 240 volts, because the odds are you last 3, 4, 5 days here without paying for anything. You can improve the system by, as I say, increasing the number of these you have. You can put 1, 2 or 3 on depending on what size your alternator is, and certainly by putting more batteries on, you can put as many as you want on. You've never heard anybody complaining about having too many batteries. It's always about too few. So the basic system, I would say 3 to 4 batteries, 1, probably 2 battery to battery chargers on a Euro 6 engine. But if your engine is an older type and you only have sort of a a 90 amp alternator, then you are very limited on you know, what you can do. So anyway, hopefully this video was of some sort of use to you. There is the information on the screen. We've also got a lot of videos on our website which can enhance and help you with you know, more details than I wanted to spend giving you on this here. It's a rough thing. If you have any problems understanding it, just give us a ring. It's 01905 771 771 in the UK, and we can talk you through it. But yeah, I mean, this is definitely the way it's going. Getting gas off the vehicle, the hassle and the cost of gas versus your electric as you're just driving along the road, charge the batteries up, and you're good to go. So hope you find this interesting, and give us a shout if we can help you. Thanks.